Hi everyone, and welcome to the Mat 211 review of Cramer's rule. My name is Julia, and I work for the tutoring centers at ASU. So we want to solve for the variables x and y using Cramer's rule for this system of equations, x plus y equals 2 and 3x minus y equals 4. So let's start by talking about what Cramer's rule is. Cramer's rule, and we're going to just talk about the 2 by 2 case here, is, so say we have some matrix equation A x equals B, okay? Where A is going to be, a 2 by 2 matrix of coefficients. Let's just say A11, A21, A12, and A22 here, okay? So that's our A. Our X is our matrix of unknowns. So let's say X and Y here. And our B is our matrix of solutions. So let's say B1 and B2. Okay. Now, provided that A, the determinant of A, is not equal to 0, so the determinant of this guy does not equal 0, then we can solve for x and y in the following way. X is going to equal the determinant of this matrix, B1, B2, A12, and A22. So that whole matrix there. Note that this is not this matrix, but in fact, it has the solution matrix in the first column and the second column of our A in the second column. And we're going to divide that by the determinant of A. So whatever this is. And that's why it can't equal 0, is otherwise we would be dividing by 0, and that's an undefined value. Similarly, y is going to equal the determinant of the matrix A11, A21, B1, and B2, where this is actually the first column of A, and this again is the solution matrix. And then we're going to again divide that by the determinant of A. So this seems a little complicated, but it's not too bad once we go through it. So the first thing we want to do is define our the matrix form of our system of equations. So we know that this is going to be, just write it over here, 1, 1 for 1 and 1, 3, -1 for 3 and minus y here. Then we'll have x and y. We'll make sure they're in that order so they multiply through correctly. And that's going to equal 2 and 4. So this is going to be our coefficient matrix A. And the first thing we want to do is take its determinant. So the determinant of A in this case is going to be 1 times -1, so -1, minus 1 times 3, so 3, which equals -4. And this is, of course, non-zero, so we're good to go with Cramer's rule. Now we want to figure out our x and our y. So I'm going to go ahead and erase y here for a second. So we want the determinant of the matrix, our two solutions, so 2 and 4 for our first column. And then the first column of, or excuse me, the second column of our matrix A here, which is going to be -1 or 1 and -1. And we're going to divide that by the determinant of A, which we already found to be -4. So we can take this determinant on the top. That's going to be 2 times -1, so -2, minus 1 times 4, so -4, all over -4. So we've got -6 over -4, and that means that our x is 3 over 2. So let's write this up here. Yeah. So x equals 3 over 2 for our first solution. Now let me do a little erasing so we can put in our y again. Just erase out those and we'll fill them again. So we've got y is going to equal A11, A12, oh, excuse me, A22, 21, there we go. 21, B1, and B2. So that'll give us the determinant of our first column, 1 and 3 of our A matrix, and our solution matrix for our second column. So we have 2 and 4. And oops. And we're going to divide that by the determinant of A again, which we know to be -4. So if we take the determinant in our numerator, we've got 1 times 4, so 4, minus 2 times 3, so -6, all over -4, which gives us -2 over -4, which equals 1/2. So we have that y equals 1/2. And that is our solution. So thanks so much. And let me clear this screen here. Move this to the next screen. So before I go, I just want to remind you all that if you are looking for any additional academic support or tutoring at ASU, you can go to the Tutoring Center's website, tutoring.asu.edu, to see all of our resources. If you're looking for tutoring services for your specific course, you can go to the tutor search tool, which you can find on our main page here, or by going to this full link. So thanks so much and have a great rest of your day.